portal for this, or I can mail the presentation. Can we do it in this? Yes. Please. Give me an email ID. I'll share Google Slides with you. Share this presentation with you. You can open it there. Whoops. Can you give me your email? Read Siju. Share. If you can open it here and present it for the people who are joining online also, so that they can also see it. They're still not gone on air. I mean, to YouTube. Just check with it. Is it back? I want air. Stand mic also. We have auto mic or stand. Actually, mic won't be necessary.
We are live streaming also, na?
Please, so I have stand podium only.
You want to walk?
You want to walk?
That is okay. You can use this. Yeah. You can use this.
He will help you.
Video at least put on the video. YouTube, I link I have given you, right? Open the link here. YouTube link. It is live. Email I have given YouTube link, right?
No, he's given me to share. Slide and share where it is. Stand here.
This WebEx you start recording.
Where it comes, share. Updates, please check the updates. Nikhil Aparajit.
So just a minute.
Can download it. Can download it. Just open. Yeah. You can open it directly in the browser. Or you can download it as PPT extractions. That also works. Turn on video files and from there only. And it's not. No, DJ. Thank you so much.
Siju, can we start?
One by one.
Okay. Yeah, sure.
Unmute and
It's on, right? What it's showing there now?
it's on. YouTube, can you open?
No, it's downloading.
Siju, when it's ready, just tell me.
This Zoom, huh? Zoom, can you log out? It's showing. Just open that.
Good afternoon. In association with IEEE India, CDAP Acts Bangalore has organized a talk on Basics of Web 3.0 and Blockchain by Mr. Nikhil Aparajit, Community Lead, Lumos Lab. Mr. Nikhil Aparajit is a BE Computer Science graduate from Priyadarshini College of Engineering, Nagpur, with a diverse experience in IT project management, operations and marketing. He has earlier worked as community development consultant at K2 Clouding and head of operations at Pro Technologies Private Limited. Sir, on behalf of CDAP Acts Bangalore, we welcome you and request you to kindly start the session.
Hello, everyone. Hello. It should be link this for now. Ma'am, thank you for calling me. Sir, it's Nikhil, it's fine. Hi guys, I'm Nikhil Aparajit.
Yes.
Just present the screen and we'll get started. So I'm Nikhil Aparajit. I'm the community leader at Lumos Labs. So let's get started. Let's get the small listing of the next slide, please.
One minute.
So,
I'm going to share the option. I'm not able to share the video screen.
but in the meanwhile, things are setting up. Let me just go through the coding scale a little bit. Can you guys tell me, have you guys heard about Web3, blockchain? How familiar are you with these technologies? How many of you guys are listening to, hearing about this term for the first time? Blockchain, Web3, Bitcoin. I think Bitcoin everyone's heard about. NFTs, I think you've heard about it. I hope. Yes. How many people have you heard about it? Okay, so let's keep this session a little interactive. I mean, constantly asking you questions and try to keep it funny, as non-professional as it can be, and hopefully let's get some value at the end of it. Okay, so this is me. I'm the community leader at Lumos Labs. I basically take care of all the community development-related programs at Lumos Labs. Let's get this. Let's set our agenda. What we're going to cover in this session. We first of all understand the fundamentals of this space. Of the Web3 space, we'll understand what is blockchain, we'll understand what is Web3 and why Web3. Then we'll also understand the difference between tokens. Then we'll understand what is a wallet, we'll understand what is an NFT, we'll understand what is a Dapp, what is a DAO, and a Metaverse. Okay? All set? Let's go. So, what is blockchain? So, how many of you guys are, I'm sure you guys are aware of SQL. Right? So in SQL, we arrange the data in form of rows and columns, right? So it's a structured way of storing data. So blockchain is yet another way of storing data, but with the use of something called as distributed computing, right? So instead of storing data on a singular system or a singular server, we use multiple computers on the network, which are called nodes, to store the data, right? And on these nodes, the data is stored in the form of blocks, right? So these blocks can be of any size, 1 MB, 2 MB, 3 MB, any size. Now these blocks store information, and every block is connected to its previous block, which in forms a chain, hence the name blockchain. Very simple. Now, if I can get access to the computer once, I'll show you guys how exactly a blockchain works. So let's do a little visual demonstration. This is connected to the internet, right?
Yeah.
Okay.
Can you switch off the mic because it's echoing?
Yeah.
It's echoing a lot.
Okay.
Switch off.
I have switched. Am I audible to the back?
Yes.
Awesome. Okay. So let's understand. Is it visible on the online? Can you check if it's visible online?
Yes, given the access. Again, share the screen now. Share the screen.
Yeah,
Share the screen.
whole screen.
Whole screen you share. Screen one now.
Visible? Yes.
Yeah, it will be visible now.
Awesome. So we can see the screen. So for example, here is a very visual representation of what a block looks like. Okay. So we'll understand what a blockchain is through this example. So essentially a block is a collection, is a type of database, right? So we store data in the form of blocks. Now this block here is an empty block right now. So what all information you can see a block that is numbered. So you can number a block 1, 2, 3, 1000, 2000, whatever you want. Then there is something called as nonce, which we'll come to later, which means number used only once or number generated only once. Okay. Then there is the data part, which is blank right now, and then there is a hash. So hash is a representation of this data on a blockchain. Now this hash is usually of 256 bits or 64 characters. Now if you see at this hash, this is like a randomly generated string of numbers, right? And if you see on this hash, if I write, for example, this is the hash for this blank database. So if I say type my name here, this hash changes. But one thing never changes, that this hash is always of 256 bits or 64 characters, right? This will never change. So now what happens in a block, essentially, if you see here also we are seeing a hash, right? You can see a hash. Here also there's a hash. This is empty. But there's something that is peculiar about this hash. Can you guys observe and tell me what is so special about this hash? Anyone? Carefully, notice on the start of the hash. This hash starts with 4 zeros, right? So this is a peculiarity of this SHA-256 or SHA-256 hash, where all of these hash should start with 4 zeros, right? Now, what happens if I write my name here? See, the hash has been changed and the color went from green to red. Means this hash is now changed. A new hash is generated. So when you essentially talk about crypto mining, where Bitcoin is mined in a cryptocurrency, what essentially happens is we mine for this nonce, number generated only once. So essentially, how many counting do I have to do? How many changes do I have to make to this particular block so that this hash starts with 4 zeros? That's what essentially we are counting at. Okay, so what if I do 1? Nothing. 2. Nothing. 3. Nothing. So how many times do I have to count until I come up with that specific hash that has 4 zeros associated with this data? So for that, I'll go and click on mine, and it will show me that I have to count 2824 times to get a hash that has 4 zeros at the start of it. So this is exactly how a blockchain functions. And when we talk about Bitcoin mining, when we talk about all these concepts that I'm going to cover on later in this session, this is what I'm referring to. So let's head back to the presentation. Hold on. Yes. Sorry. I can use the mic? Yes. Use the mic? Okay. So now that we've covered what is the blockchain, let's go to the next slide. Okay, this is a very blanket term that is used almost everywhere. Everywhere you see startup founders talking about Web3. What exactly is this Web3? So now we understood blockchain. Blockchain is essentially, Web3 is essentially the form of internet that is built on top of this blockchain technology. Right? This is essentially the next version of internet, which is based on around decentralization and user controlling their information. So let's understand how we got here. Next slide, please. Okay, let's understand the evolution of internet. I think I don't need to teach you guys how internet evolved. But when essentially internet was conceptualized for the general market in the 1990s, we said internet was like a big library, right? You would access the internet through a web browser. And you could go to a website and you could view the information. So you could read it, right? You could go to AOL.com or Bing.com or Yahoo search, and you could search for articles and you could read for it. You could search for scholarly research papers and you could read those pages. But that was the only extent of how internet communication and internet usually work. So it was a read-only form of internet. You could go there and you could read the content that was essentially generated by a few research fellows and these. Then in the late 2000s, there came the era of Web 2, which we currently live in. Now, companies like Google, Facebook, Amazon, Instagram, these companies came up with a concept of user-generated content. Right? Now, what do I mean by user-generated content? So, Aman, when you are on Instagram, whose content do you see? If you put out a picture, who creates the content? Users? So when you watch videos on YouTube, who is the creator of those videos? Well, like you and me, right? It's not like the population is making those videos. So in the era of Web 2, basically, users generate the content. So now with this era, you can not only view the content on the internet, but you can also create it. Not just that, you can also react to the content that is already there on the internet. So you could like that video on YouTube or dislike that. You can tweet about your favorite creators on Twitter, or you can put a story on Instagram. Right? All of that is a very immersive form of internet. But there is one fatal flaw. This content is not owned by the user. So now what's the name? Kalyani. Do you use Instagram?
Yes.
So the images that you upload on Instagram, who owns those images? Instagram. So if you have the misconception that the images that you upload on Instagram, the videos that you put on YouTube, or the tweets that you put on Twitter are owned by you, you're gravely mistaken. All the data that you see on the current form of internet is actually owned by the centralized entities, those companies that you use those applications. So, for example, if YouTube does not like my video or simply doesn't like my face, they can basically ban that video from people from viewing. There's a very popular example to this. During the United States presidential election, Donald Trump was accused of inciting violence to the Capitol riots, and his Twitter account was banned. Now, the irony here is he is the president of the United States of America, and his Twitter handle gets banned. So, who's more powerful, the US president or Twitter? So, you see the problem, the recurring problem in this form of internet, which is much more immersive, to be honest. Like those old days of HTML pages and those old clunky websites are gone. We have interactive websites with JavaScript running to make the website look as beautiful as possible. And we have convenience and fun like never before. Social experiences that never has been experienced by our parents' generation. But the fatal flaw is all the data that you generate on this internet is not owned by you, but is owned by some highly connected individuals, which is not a good sign. So Web3 is built on this belief that users who are generating the data are also capable of controlling the data. Right? And that is what Ethereum is. So here, you not only read the content, you not only write the content, that is create the content, but you also own the content. Next slide, please. So why Web3? Now let's understand in detail what are some of the reasons why Web3 is so essential in this space. So Web3 is open, right? It's open for all. It's not restricted. For example, some websites are banned in specific places. So you can't access Google in China. You can't access Facebook in China. Or you can't access certain specific websites in certain parts of India, right? Because of certain government regulation. Web3 is beyond this. So there is no censorship of information. So it's open. So it's permissionless. You don't need permission to access that internet. Right? You don't need permission of your internet service provider to access Web3. You also, this decentralized that we talked about, the data is owned by the users of that. Ownership of your data is obviously in the hands of users. It's uninterrupted, right? Because it does not follow the model of a centralized server. It's built on top of a network of computers connected, interconnected. Oh. Okay. Sorry. So sorry. Guys from YouTube, I'm really sorry. So I'll try to not move around a little bit. So the data is immutable. Now, what is the meaning of immutability? Can anybody tell me? Raise your hands, please. Immutable. What's your name? Shubham. Good answer. They can't be changed. So I showed you guys the working of a blockchain on that website, right? When you change the hash, it goes to red. So on a blockchain, if I change even a single digit, even if I change a single bit of information, the address of the previous block is lost, right? Hence breaking the network. Hence, when you basically mine the data on a blockchain, you really can't change it without again mining that information, without again going through the exact same process, which makes the data put on blockchain immutable, that is unchangeable. That is one of the key advantages for which we are using decentralized finance as one of the primary use cases on blockchain. Next slide, please. So, how does a blockchain work? How does a transaction on a blockchain work? Magic. No, it doesn't. Next slide, please. So this is basically a rundown on how a blockchain transaction or a cryptocurrency transaction works. So with this, we'll understand the basics of cryptocurrency as well. So my friend Rob wants to send to his friend Laura 0.3 BTC, okay, Bitcoin. He wants to send 0.3 Bitcoin. So basically, Rob opens his Bitcoin wallet, right? He scans Laura's QR code, okay. Then he fills the amount and the transaction fee that is required for sending that amount, and then he hits send. My part, Rob's part is done. Now on the machine end, what happens? The wallet basically signs the transaction. Yes, the wallet basically signs the transaction on Rob's part using its private key. Right? We'll come on that. What is private key? What is public key? We'll come on. Right? Then the transaction is propagated and validated by the network. So as soon as the transaction is done, it is shared across various nodes of that network, and it is validated by someone called as miners. Right? So you'll understand what mining is. Right? Then miners do some magical stuff on it. They basically do proof of work for Bitcoin's case. Then that mining is essentially a computational process. So they use the GPU power of your computer to solve for that nonce number that we were talking about, right? The blockchain that I explained to you, right? So it basically tries to deduce when do I get the flow zeros, right? Essentially, if I have to boil it down to that simplicity, so that nonce is what the computers are fighting for. So whichever computer gets it the first, their block is used to mine the next transaction. So the miner who solves the proof of work propagates the block onto the next node. That node verifies the result, and then Laura sees the confirmation of the payment on her network. This is how decentralized Bitcoin transactions work. Okay, next slide, please. Okay. Next slide. Oh, let's understand what are wallets. Okay, we talked about Raw using a wallet, Laura using a wallet. What is that? Next slide. Well, what is about work? You think about it, but what are exactly crypto wallets? Next slide. Well, crypto wallets are basically ways for you to store your information. So just like you need an internet browser to access the internet, you need a wallet to access the Web3 internet or access anything in the Web3 ecosystem. So these wallets are like your identity and a form of payment, both at the same time on Web3. Now, there are two kinds of wallets. There is one called as the custodial wallet, which is basically hardware or extension-based wallet. So either it can be like a pen drive which you own, which has all the cryptocurrencies downloaded in an online format which you can store. That's called a hardware or a hard wallet, right? And then there is called something called a software or extension wallet. Extension wallets can be as simple as a Google Chrome extension. One of the most popular software wallets is MetaMask. So MetaMask is a wallet that can be used to do transactions in Web3 and also to used as an identifier of your identity on the Web3. Right? Then there's second thing called as non-custodial or crypto exchanges. Non-custodial wallets or crypto exchanges. So non-custodial wallets work very similar to stock trading apps. So if you have a demat account, so when you buy stocks and trade stocks, your stocks are stored on your demat account, right? So it's very similar to that, but this is for crypto exchanges. So when you buy or sell crypto, when you buy or sell those cryptocurrencies, those get stored on your non-custodial wallet. They get stored on your crypto exchange. Instead of you having the control of it, that exchange has the control of those wallets. Yes, next. So let's understand what are NFTs. Okay, so we're moving quite fast. Yes, we're moving quite fast. Any doubts so far? What is Web3? What is blockchain? Any doubts so far? Any questions? I can't see the live stream, but any questions on the live stream? Yes. Can we see if there are any questions? No? Okay. All clear? अब तक सब समझ रहे हैं? Yes. Yes, sir. So, yes. So, just like how, sir, if I want to access google.com, I need Internet Explorer or Google Chrome or Microsoft Edge. Similarly, if I want to access, say, a Web3 app like Uniswap or a Web3 app like, say, MetaMask, or a Web3 app, any Web3 app basically that is called a Dapp, I need a wallet. So that wallet is like my point of entry to that ecosystem. That's how I get identified on a Web3 ecosystem. Instead of my name, so when I say, for example, I'm using Gmail, so whenever I am signing to a new website, they ask me an option of signing up with Gmail, right? Sign in with Gmail. So instead of using my original identity, I will use my Gmail account as a form of identity. So Web3 wallets work in a similar way. So instead of you signing up with Gmail, you're signing up with MetaMask. Right? MetaMask is like your identity. MetaMask is a wallet. So wallet is like your identity and a form of payment on this ecosystem. I hope that answers your question. Yes.
What is permissionless?
Permissionless. So, for example, permission to access, there's like a variety, permission to access certain information. Permissionless, as in you don't need permission of an ISP to access internet, access the Web3 internet. That's what I was referring to.
When you're talking about wallet,
Yes.
to access Web3,
Yes.
so that wallet should be full of money, then only.
No. You don't even need money to access Web3.
So what do you mean by that wallet? It's a token, right?
Yes. So it is a place where you can hold tokens or cryptocurrencies, which is a
Currency,
previous slide.
right? So currency
Yes.
is for money only.
Correct. Correct.
Money should be there.
Correct.
Maybe there and may not be there. Suppose it's there,
Hmm.
and I am using it on Web3,
Hmm.
then there is a chance of security breach or
Correct.
something like that. So whether we are safe or not.
There is a chance of security breach, as in how I mean by that. So unless and until you divulge your private key to someone, so if private key is like your signature. So if you don't sign the transaction, you can't get duped on a wallet-based transaction. If you willingly share your private key with someone, that's as like you're sharing your Gmail password with someone, you can't actually get hacked by traditional means, if that makes sense.
Sir, as you know, blockchain is decentralized
Right.
and distributed ledger. So what is distributed ledger?
Okay, so by ledger, I mean there is a word in Hindi called as Bahi Khata. I hope you understand Bahi Khata, register of inflow and outflow of transactions. So a distributed ledger is like an open book of all transactions happening on that particular blockchain. So for example, Bitcoin. So if you, for example, let's take Ethereum. Ethereum there is a website called ETHScan. So you can go on ETHScan and basically check out all the transactions that are happening on blockchain. I can actually show it to you. Just a second. I'll show you an example of how transactions look like. Hold on. We are allowed to do like this. I hope it is visible to other students as well. So this is a visual representation of how crypto transactions work. This is like a cartoonish way of telling you how transactions happen on Bitcoin and what is the ledger. Okay. So on my left, you can see there is, I'll just shift to Bitcoin because it's recognizable. And on right, you can see. So essentially, these are the blocks. Okay. These are like buses. And all of these people that you see here, these are people, these are all individual transactions. So if you click on any one person, you can see the transactions that are happening on. Right? These are pending, waiting in line. Right? These are getting stored in something called as a memory pool. So all the transactions that are incomplete get stored in a line like this. On the right, you can see there's a line, a big line of transaction, which are waiting to be recorded on a blockchain. Right? So all of these are pending transactions. This is a block. Whenever a transaction's due is taken, so whenever someone pays a transaction fee or a gas fee, they get into a block, and their block is basically mined on a blockchain. So this is how a transaction works on cryptocurrency. This is exactly what a ledger is. Now, if you want to see exactly how ledger looks like in real life, there is a website called EtherScan or ETHScan. You can go to EtherScan. So this is a ledger, right? This shows all the transactions that are happening on the Ethereum network to and fro. So a distributed ledger in that regard is basically a register of transactions that is happening all across the globe, and everyone has access to what transactions are happening, right? So in that way, it's a very decentralized form of transaction. So when I talk about open and permissionless, why is it open? Because all of these transactions are visible to anyone. So if anyone is trying to say hold money or trying to steal crypto or something like that, those transactions are visible and people can stop it, right? Let's go to the next slide. Yes.
So as we mentioned, source
Right.
hash for previous one and own hash. Right. So first block of the blockchain is called Genesis block.
Correct.
So that doesn't contain hash.
Correct.
Its own
It's
hash.
again by
So what is the security of first block? If someone has to manipulate the data of first block, so how to secure it?
The thing is, every blockchain's first block data, it's a Genesis block, so it actually can't be manipulated. Right? It is built in top with the protocol, so it can't be manipulated in some.
This is for solidity.
I know some people might be getting bored, but yeah, Solidity is the language that is used to build smart contracts on Ethereum based net. This is correct. Some more, yeah. Okay, what are NFTs? So it's not nice factories. Okay, next slide, please. It's essentially non-fungible tokens. Okay, so before understanding NFTs, let's understand the difference between token and what I've been talking till now, cryptocurrencies. Okay, let's go back a few slides. Go back. Go back again. Go back again. Yes. So let's understand what are cryptocurrencies and what are tokens. So right now I talked about Bitcoin. I did some names, Ethereum also I did. What are these? These are cryptocurrencies. What are cryptocurrencies? These are native currencies for a specific blockchain. So for example, the currency that is used to run the Bitcoin network is called the Bitcoin. The currency that is used to run the Ethereum network is called Ether, or generally people call it Ethereum. Right? So these are currencies that are used to run that specific network. What do I mean by that? So when I'm running transactions on a Bitcoin network, say you are having a computer and you are a Bitcoin node, and I'm using your computer's resources to basically facilitate a transaction. So you must get something out of it, right? I'm using your CPU, your computational power and electricity. So the fees that you get is in the form of Bitcoin. That native form of currency is called as cryptocurrencies, right? These use cryptographic signatures as a form of its. So these are created using cryptographic signatures, like SDK, etc. Right? Now tokens. What are tokens? Now tokens do not have their own blockchain. They are built on top of a blockchain. So for example, a very popular token is what is Polygon. Right? Polygon is actually an Indian company started by Indian founders, which basically is one of the most popular ways of doing transactions, gasless transactions on the Ethereum network, which is built on top of the Ethereum network. So it does not have its own blockchain, right? It's built on as a layer 2 protocol. So it's called as a layer 2 protocol. It's built on top of the Ethereum blockchain. So they do not have their own native blockchain, and that's how you can separate a token from a cryptocurrency. There are various kinds of tokens. So on Ethereum, there are something called as ERC-20 tokens, which are used for transactions. There are ERC-1155 tokens, 115 tokens, which are used for NFTs, which we talked about. Then, so tokens can be programmed using logic, smart contracts. So basically, tokens have a utility. Tokens can be used to put code on blockchain. This is something very interesting for people from CDAC and engineers in general. That if you are someone who's a coder, if you're someone who's a developer, putting smart contracts, that is putting code on blockchain, is essentially your way of getting into Web3, your way of building something on the Web3 ecosystem. Next slide. Yeah, I'll try. I want to talk here, and the thing is the mic is here. So if I talk like this, yes. Go back a few slides. Yes, NFTs. Okay. Yes. That is very cute, but let's understand what are NFTs. Okay, so I talked about tokens. Now, tokens are simply like a note in a currency system, right? But what are non-fungible tokens? Why are these so hyped around in the industry, and why is it so important to understand what are NFTs? So, for example, I'll show you with an example. So, I have a 20 rupee note, right? So, this is a common 20 rupee note. So if Aman has a 20 rupee note, I can go ahead, I can give this 20 rupee note to him, and I can take his 20 rupee note, and these tokens, these mean the same thing. Both of them value are 20 rupees, right? Now, this is called a fungible token. That is a replaceable token. That is a token that can be used again and again, right? A token that is interchangeable in value. Now, what if the government of India tries to do something special and launch a gold 20 rupees token? Like that 20 rupee note is built of gold only. Okay, now that is very unique, and the government says we'll only print 20. So 20 rupee notes, golden currency, and only 20 became unique, right? It became so unique that people will pay more than 20 rupees to buy that note because it's unique, right? It has value. It can be distinguished from other 20 rupee notes. That's essentially what non-fungible tokens are. Now, when it comes to notes or physical objects like paintings or art or etc., I can actually create distinction using physical characteristics. How do I create uniqueness in a digital scenario? This is where NFTs come in. right? NFTs are a way to create digitally unique items, right? NFTs are a way to create digitally unique items which have an owner. Every NFT has an owner. So if I create a painting and if I put it on Instagram, I can be the owner, the first owner of that NFT, which proves proof of ownership. How many of you guys have done graphic designing before? Like made posters or something for your college, or ever built something on Canva, or built some happy birthday card for someone? Ever? Never? On Canva? Anyone? Yes. Okay. So, have you ever noticed that graphic designers are the most underpaid people in the IT industry? Have you seen this? Like the most work that they do, and they are still the most underpaid. Why? Because they can't differentiate their unique work, and most of the times you've seen this artist, they make their work and they upload it on the internet. Someone plagiarizes that work, and they never get their work. Right? Musicians create music, put it on YouTube for people to view. Some big music label company copies their music and never gives them credit, right? So how do these artists, how do these creators basically create content like we talked about in the Web 1, Web 2, Web 3 slide? How do they create content and make sure that they own that content? Well, NFT is one answer to that question. NFTs create digital ownership. They create digital uniqueness. And now I can transfer ownership. So for example, if I'm a YouTube content creator and I want to share a specific exclusive video only with the people here at CDAC, I can do that with the help of NFTs, and I can create digital uniqueness. Now, are there ways to trick this system? Absolutely there are. I think if I stop and ask questions how you can beat this system, there will be 5 more answers, right? But is this a good way to prove proof of ownership of digital items? Absolutely, right? And currently, if you see, the most amount of NFTs that are owned are in the form of digital art, right? JPEG images. But there are also NFTs that can be stored in the form of GIFs, movies, videos, podcasts, audio, music, etc., etc. And not just that, NFTs can also be used as a form of identity on metaverses. Because it's a digital form of identity, it can be used as a very design focused form of identity on metaverses. Right? So there are n number of use cases of non-fungible tokens on a blockchain and basically securing proof of ownership.
How is this difference that
Very different, sir. This is on a chain. So because of which the ownership is registered as a form of hash on a blockchain, which means your information, your ownership is immutable.
there are some you can prove it?
Yeah, you can prove. This is also one more way. Here, for digital watermarking, you have to go through a centralized agency to register that watermark. So, for example, if I'm registering that movie in, say, an Indian context, that watermark is active for the Indian context. In US, somebody can plagiarize that, right? So that is specific to that.
You can prove, right?
Yes, absolutely you can prove. I'm saying absolutely you can go and prove. But the fact is, so most of the times what happens is, as I've explained, the content uploaded on social media, for example, is not owned by you, right? Because ownership of that information is to Instagram or Facebook or some company like that. So in those specific scenarios, NFTs can become a viable option. I can prove ownership of my own content. Digital watermarking won't help there. They don't count digital watermarking as one of their forms of identity.
But this you need to have your own set of keys.
Yes, absolutely. Yes. Any more questions?
So if I want to sell my art, that should be in the form of cryptocurrency.
Though artwork need not to be in the form of cryptocurrency. So it can be sold using cryptocurrency as a form of exchange. Hope that answers. Next. So what are dApps? So just like how Facebook, Instagram, YouTube are apps or applications, dApps is a short form for decentralized applications. So I'm sure you guys are aware of full stack development. Front end, back end, database, right? That's how a website is built. That's how an application is built, right? So a decentralized app, if I replace the database part of a centralized app and I replace it with a smart contract, if I put a smart contract in place of a database and I upload some of the data, some of the identification data of that app onto the blockchain, that app essentially becomes a decentralized app. Because now the database or how the data is being handled on that particular app is not governed by, say, MongoDB or SQL, but is governed by a smart contract built on top of a blockchain. So that essentially is a dApp. This ensures two things: so privacy and censorship resistance, right? So that app becomes censorship resistant. A government entity or a private entity can't sabotage it because it is not owned by one single entity. It's distributed in ownership. Next slide. So what is a DAO? And nearing the end of the demonstration part of it, what is a DAO? DAO is basically an internet community with a bank account. Next slide. So what does exactly mean? DAOs stands for Decentralized Autonomous Organization, right? It's basically a community of people coming together on the internet and deciding to work for a cause. It's like an NGO, but with a bank account, right? Now, what you can do with DAO is basically, if you have, say, for example, you people are interested in music, right? And you want to take up freelance music gigs. Now, you come together in a DAO and basically create a shared wallet and vote on who gets what. So DAOs are essentially like truer sense of democracy on blockchain. So you can basically on a DAO you can have members. You can create tokens on a DAO and you can share those tokens amongst the members of that DAO. And now with specific amount of tokens in your hand, you are basically ready to vote on a DAO on proposals. So if that DAO decides, so we will participate in the upcoming YouTube fan fest. Just an example. So then every member is basically there to vote on it. So if more than 55%, for example, people on that DAO vote yes, then that DAO will basically go and participate on that thing. So DAOs are usually not this simplified. Next slide, please. There are various kinds of DAOs. So I'll explain a few of them that will give you an idea. So for example, there are something called as investment DAOs, right? So you can become a member of those DAOs. You can basically buy those tokens. And if you want, you can basically invest in startups using these DAOs. So if the DAO basically decides to invest in a particular startup, your shared pool of money will be invested in that startup, right? So a lot of venture capitalists are building those DAOs. There are media DAOs. So for example, news organizations need to be as transparent and as not governed by profit kind of thing, so that we have honest and just news, so that the news is not biased. So one way to solve that problem is using a DAO. So if there is a news DAO which is governed by the community of the people that holds token for this news DAO, people can vote as to which mode of advertising, which mode of news reporting, what kind of news that DAO wants to cover, right? So it's a very decentralized way on the blockchain to basically do fun stuff, right? There is great DAO, which is like a DAO for product managers. So if you are someone who's interested in that sort of stuff, you can go on the DAO and basically get freelance product management projects. Next slide, please. Now we come to the metaverse part of things. So what is a metaverse? Now we talked about Web3 as the next form of internet. Now metaverse, according to me, is the next form of social media. Next form of social media, a more immersive way of interacting on social media. Right? Now this metaverse is enabled around immersive activities, right? Immersive activities like you actually being a part of your social experience. Right now, our social experiences are restricted to Facebook's feed, right? We scroll through the feed of Facebook, Instagram, Twitter, and that's how our social experiences are governed by. That is changing with the advent of Reels or YouTube Shorts. So now instead of just looking through random scroll of pictures, you can actually see people performing for 90 seconds and you can scroll through that. Now, essentially, Metaverse is the next form of social media, which is geared around you actually being in the center of action. How can you do that? Basically, you can do that in the form of AR-based metaverses, where you can have a smartphone which has an augmented reality mode on it, and you can actually see the metaverse around you inside the real world. Or you can basically go through a VR route, right, where you have virtual reality headsets on your eyes, and you can actually become a part of that immersive experience. But there's a third kind of metaverse that almost everyone here has experience in some form. So how many of you guys here play mobile games? Very studious people you are, guys. Nobody has played mobile games. Come on, don't lie. Okay, how many of you guys have heard about Minecraft? At least heard about it. I'm not asking play it. So what is Minecraft essentially? Minecraft is a player-based experience, an immersive player-based experience where I am inside a world and I build that world and I govern that world through my social experiences. So there's a builder mode, right? There is no danger and you can build whatever you want. And there's some crazy worlds that people have built. Like people have built a computer inside a 16-bit operating computer inside Minecraft, using the resources inside that game. So people are very creative when it comes to creating worlds. So metaverse is just like that. So one metaverse that you have already experienced, mobile games, for example, PUBG or BGMI as it's now called, it's also a form of metaversal experience. You having an avatar, going into a world and playing that first-person shooter game and interacting with your friends while you're playing it. That's a social experience. That is the next form of social connections, right? Earlier, people used to connect on, say, Orkut chats, or in the old days, or MySpace, or some older form of social media, Vine. And now people are connecting in these metaverses that are geared towards a more immersive social experience, right? How many of you guys have heard about the game called Pokemon? Pokemon Go. Yeah, right. People used to go crazy catching those Pokemons in streets. People have met through accidents also. But essentially, that was also a form of AR-based metaverse. You could actually see those Pokemon in real life using your camera, phone's camera, right? So that was a social experiment. That was a metaverse. That is exactly next slide, please. So how your experience with your metaverse is basically designed is through these 7 layers of metaverse, right? There are 7 layers of how your experience is basically defined on a metaverse. So the first layer is the experience layer, the actual layer that you are interacting with. The experience layer is where you play the games, you do this esports on FIFA, or you shopping, etc. Right? Then the second layer is the discovery layer, where how you come to know about that metaverse. So how did you come to know about Pokemon Go? You saw something ad on news, or you saw a Google ad or something like that. That's the discovery layer. That's how you come to know about that metaverse. The third layer is the creator economy. Now, Pokemon Go was made by Niantic, right? That was the company that made it. The Pokemon company was the owner of the IP that was used on that particular game. But if you go on Minecraft, who creates the content? People like you and me, right? You go and create those magical worlds and you experience that metaverse as you like it. So there's a creator economy part of it. Right? You work on that metaverse's design. Then there is the spatial computing. There's the back end side of things, right? The 3D engines that are required to build those games. So PUBG is built on Unreal Engine, if I'm not wrong. Correct me? Yes, Unreal Engine. Unity engine is one of the most popular gaming engines, open source gaming engines that is used to build games and metaverses. So Unity, then VR, AR, and XR based technologies that are used to build so Oculus headsets, which is owned by Facebook, which is one of the key technologies that Facebook is investing in for VR based metaverses. Then obviously geospatial mapping. So if you want to build a realistic world inside a virtual world, you need to map the geospatial surroundings of your real world then. So for that, those technologies that are used. Decentralization, which is very, very crucial, which is your identity using edge computing, AI agents, and blockchain, making sure that your identity stays safe. Yeah, you stay anonymous on a virtual world. Then human interface. So how do you interact with the metaverse? So it can be through a computer, it can be through simply a mobile phone, it can be through haptics and gestures. Obviously, you need variables. So Facebook is going through that variable route. So you buy those Oculus headsets, and then you become a part of their metaverses. Some companies, including Lumos, is going through computers and smartphones, where because that's the most accessible way of entering a metaverse. And then there is the infrastructure layer. All of this is built on top of the 5G infrastructure that has been developed, or the 7 nanometer chips that Apple and Intel have been able to develop. Sorry, Qualcomm have been able to develop. And because of these faster GPU processing, faster CPU processing, we've been able to actually build a metaverse that is closer looking to reality, right? Because if you see in the 1990s, in the eras of Nintendo DSs, we had those metaverses that were 2D or 3D in nature, right? You could actually see the Pokemon there, they were not real. But if you check out some of the metaverses that are being built now, they're very realistic, right? Some are very cyberpunk 2077 vibe. Some are as real as you're walking inside like a Google Street View, right? So this is happening because of the infrastructure layer. Next slide, please. Now, what is Lumos doing? So Lumos Metaverse is basically a metaverse for builders, for developers like you who are interested in the Web3 ecosystem. So people who are interested in this open source Web3 ecosystem, we are building a metaverse for them, which is like a one-stop shop for all things Web3. And that's what we've been building. We've recently raised a fund. We've raised about $1 million in seed fund, and we are currently building our product on its MVP phase. So very soon our product will actually be available for live viewing, and you guys will be able to take experience of that product, for which we are actually opening up a whitelist. Next slide. Okay, let's go back slide. We're building a whitelist for developers to basically register for that and become the early adopters of our product and give us feedback on the product. So this is a QR code here on the stand, and I'll also share it on the screen, which is the link to the Discord server where you can basically come and join and wait until the whitelist is made public. And we also have a hackathon for students and developers basically coming up in the next month, which is an open Web3 open innovation hackathon, wherein if you have a Web3 product, we have a prize pool of over $100,000 and more, basically to give out to developers who are building on Web3. So we are opening the pre-registrations for that right now, right here at CDAC. So if you want, you can register for it with the team, or you can fill out your individual information and you'll get email confirmation for the same. Next slide. Next slide. Okay, so this is the QR code link. You guys can open up your mobiles and scan to join the Discord server. This is the link to the Discord server where the whitelist will be made public. I'll give you guys 1 to 2 minutes. You guys can go ahead and register.
One question, how many of you are actually on Discord?
Yeah. Yeah, I see a couple of people.
So, there's like we also have the information, so which you have signed in. So if you don't have Discord as well, we would after the event obviously send you like the relevant links on your email as well. So probably you can download it as well. But yeah, you can take a picture of the QR code and put it out and download if you are interested.
Yeah. This is the pre-registration form for the hackathon. So this QR code will take you to a Google form basically, and you can go ahead and register for the hackathon. If you are interested in the Open Innovation Web3 Hackathon, you can go ahead and register. You will get an email confirmation for the same, and then our team will be basically in touch with you for the same. This would be a 3-month-long online form of hackathon. So you guys can build your project, make up your teams, and then submit the project for the build phase, and then the project will be circulated forwards. In the meanwhile, if you guys have any questions, you guys can go ahead and ask. So in summary, we've understood what a blockchain is. We've understood what Web3 is. We've understood the difference between tokens and cryptos. We've understood what an NFT is. We've also understood what a DAO and a Dapp are. We at least can make differences and tell maybe full forms to people in conversations. And I hope that you guys have gained some basic information about what this world of Web3 really is. And I hope that I have motivated you enough to at least go ahead and Google a few of the terms that you've seen here. I've also, so in the footnotes of this presentation, I've added a few resources that if you want to explore more, you can go ahead and check it out. These resources will be shared with you on the email. After this presentation, I think a couple of days, the team will share you a email where I'll share this presentation and a few important links that you can maybe check out and explore the world of blockchain even better. With that, I come to an end of the presentation. Next slide. That's it. Thank you, guys. If you guys want to reach out to me, next slide. That's just for fun. If you want to reach out to me, this is my social handle. You can reach out to me on LinkedIn and Twitter, Nikhil_Aparajit. If you want to network with me or if you want to ask some questions personally, you can just come up here after the session is over and we can have a quick chat about it. If you have any specific, yes, sure. If you have any specific tech-related questions, if you want to get connected with experts, you can join the Discord server. We have dedicated experts working around the clock to basically help you guys transition in this journey. Also, we have some special gifts for you. So we have T-shirts for you as a token of appreciation for listening to me for almost 1 hour. So I'll be giving out those T-shirts. You guys do mention your sizes and the T-shirt will be distributed based on that. I also have some note cards for you. With that, thank you so much for inviting me. Thank you so much.
So thank you, Mr. Nikhil, for visiting CDAC first and then enlightening all our students and staff and giving us such a wonderful talk. We really appreciate that. Okay, and then I request Mr. Shanmugathan, Joint Director, CDAC Bangalore, to give you a small memento. Thank you. Also, my sincere thanks to Mr. Munir Mohammed, Senior Program Manager, IEEE, for introducing Mr. Nikhil and coordinating with at CDAC Bangalore for successfully delivering this talk. Okay, lastly, special thanks to all the students and staff for joining either physically or online. Thank you all. I request you all.